Percent composition. So the amount of each element in a compound we can express as a percentage by mass, and that's essentially what we're going to be talking about today. This brings us to the law of definite proportions, which says elements of a particular compound are always found in the same proportions. So it doesn't matter, let's say for water, it doesn't matter where you find it or how much you're dealing with. If you have a whole lake of water or you just have a little bottle of water, the amount of hydrogen and the amount of oxygen are going to be found in the same proportions no matter what. That's what the law of definite proportions is saying. We can express that as a percent, and we want to do that as a mass percent. So the weight of hydrogen and the weight of water, or mass to be more precise, is always going to be the same, definite. Two ways that we can do these calculations. So if we want to know the percent of each element in a compound, and again by mass, we can do it one of two ways. One, we can actually have the masses of the elements in the sample and then divide by the whole. Or two, we can essentially do the same thing, but we can start from the formula. So let's work through two examples. Say we have a particular compound here, CO2, and we want to know what the percent composition is of each element in that compound. If we know that we have a certain mass of carbon and we have a certain mass of oxygen, and we have the formula here, we also have the total mass, so we can actually do it just from the numbers for this one. We can find out what is the percent of carbon, what is the percent of oxygen in this compound. And you've done this as a percent calculation many times before. We have the mass of carbon, 5.600 grams, and we have the total mass of the compound, 20.52. We divide 5.600 by 20.52. Grams cancel out. We multiply by 100 to write it as a percentage. We do the same thing for oxygen. Its mass is 14.92. The total of the compound is 20.52. Multiply by 100 to express it as a percentage, and we would end up with it being 27.29% carbon and the rest 72.71% oxygen. Now there's only two things in it, so as you find the first one you can just subtract from 100% to find the second one, or vice versa. Either way, given the numbers, you can express what the portion of the whole is as a percentage fairly straightforward. The second way is a little bit more complicated, but not too bad. If we have the formula of a compound and we know the molar mass because we have the formula, we can assume that we're dealing with 1 mole of the compound. So we could say that we'll look at the molar mass of each of the elements in the compound, we'll find out what the molar mass is of the whole compound, and then express that as a percentage for each of the elements. So use the molar mass of each element over the molar mass of the whole compound and express it as a percent. Let's say we had CO2 again. Just given the formula and a periodic table with molar masses on it, we would find that the molar mass of carbon is about 12.01 grams per mole. The molar mass of oxygen by itself is 16.02, but remember this is CO2, so we're going to have 2 of these oxygens. So in total, both oxygens are going to weigh 32 grams per mole of the whole. The carbon contributes 12.01 grams to the whole. So we could take the total of that, the whole molar mass of the compound, and find out how much of that whole is carbon and how much of that whole is due to the oxygens, and write it as a percentage. We know that the carbon in the compound weighs 12.01. We divide that by the mass of the whole thing in 1 mole. All the units cancel out, and we would rather not write it as a fraction essentially, so we multiply it by 100 to put it as a percentage. For oxygen, we can do the same work. We can say, okay, well, there's 2 oxygens that weigh 16 each. That is the portion out of the 44.01, or the whole molar mass of the compound. Multiply that by 100, and you get 72.71. Again, there's only 2 things. Once you have one, you know you have the other one by subtracting from 100. And we would have the percent composition either way, from the actual numbers given or from the formula.